Chapter 2.2, Separable Equations. So we have dy by dx is equal to e to the power of 3x plus 2y. So basically the takeaway from this question is kind of a review of your powers of e, okay? So we could rewrite this thing over here as saying dy by dx is equal to e to the power of 3x multiplied by e to the power of 2y. Recall that any two terms that are being multiplied of the same base raised to some power, we can add those two powers on a single base. From here, what we could write is the following. I can multiply my dx on this side here, and I can take my term of y and divide it on this side over here. Okay, so what I'm going to do is I'll say e to the negative 2y dy is equal to e to the power of 3x dx. So all I did was take e to the 2y and I divided it on this side. As opposed to putting it on the denominator, I just brought the exponent upstairs and made it negative. All right. From here, what I can do is I can integrate both sides, as we've learned in Cal 2 or calculus, any course you took in CEGEP or elsewhere. The the integral of e to the negative 2y very simply becomes negative 1/2 e to the negative 2y, and that is going to be equal to 1/3 e to the power of 3x plus some constant. Now this constant is some term. You could put it either with the y's or with the x's. I like to leave it with the x because naturally we've been taught to always isolate y. And then from here, what I could do is I can remove this negative 1/2 that's being multiplied to this function of y and write the entire equation like the following. So I could say e to the negative 2y is equal to, by dividing by negative 1/2, negative 2 over 3 e to the 3x, and plus c. So the reason why I'm not taking this negative 1/2 and applying it to that c is because we don't know what this constant is. It's some value. It could be 5, it could be 10, it could be a million. So when we divide it by negative 1/2, we can leave it as c because we're already undergoing the assumption that this is a constant term. And therefore our final answer that you can present is like this. There's no need to take the ln of both sides to isolate for y because we already have all of our terms of y on one side and our terms of x on the other side.